All right, hello, welcome back. We are doing 8.2 arithmetic sequences. Okay, I think I like this one. Okay, so let's talk about what an arithmetic sequence is. We already know what a sequence looks like. You know what? I don't think I like this line. Okay, I like the line here. Okay, arithmetic sequences. A sequence of the form. So you have your first term is A, and then you add D, and then you add 2D, and then you add 3D, and then you add 4D. You keep adding D, okay? And so here, this here, of course, is your first term. This is your A1, okay? And then over here, this D that we keep seeing showing up over here, this here is our common difference. It's what we call it, the common difference. Okay. All right. Because if you notice, the difference between these two terms is D. The difference between these two terms will be D. The difference between these two will be D. The difference between any two terms will be D. Okay. All right. So, it turns out that for arithmetic sequences, we do have a formula for the nth term. Um, so the nth term is always going to be found by A1 plus n minus 1 times D. Okay, so this is the formula that we use to find the nth term. So this is our nth term formula. All right, so let's take a look at an example arithmetic sequence. So if A equals 2 and D equals 3, then our our sequence, our first term is going to be 2, and then 2 plus 3, and then 2 plus 2 threes, and then 2 plus 3 threes, and 2 plus 4 threes, etc. Right? And that would give us 2, 5, 8, 11, 14. Okay. And you can see here, you just keep adding 3. So if you add 3, you get 5. Add 3, you get 8. Add 3, you get 11. Add 3, you get 14. Okay. This is probably just a fancy way of doing that. Okay. Let's take a look at this next example. Given this arithmetic sequence, 9, 4, -1, -6, negative 11. So clearly D is going to be a negative number because we keep getting smaller, right? And if we're adding something to get the next term and we keep getting smaller, that must mean you're adding a negative number, right? Okay, so what do we know? We know A1 is 9, and we know that D is, what is D? 4, what's the difference here? If you take a look at the difference here, the difference between these two numbers, you might think of it as 5, but the order actually does matter. Let's go up here. Oh, okay. The order does matter. So you have to do, you can do it this way, A2 minus A1. Okay. Or if you want to do it more general, we can say AN minus the one before it, right? We know this is nth term, and this is the way we write the one before it. Okay. All right, so over here, the order matters, so we have to do 4 minus 9. Okay? Which is negative 5. So it's negative 5, not positive 5. Okay? And we said it was going to be a negative number because we are decreasing in our sequence. Okay? So make sure that when you do this, the order matters. Okay? You always have to subtract the one before it. Okay? Okay, so if we know those two pieces of information, then we can write our write the AN formula. Okay, so we can do that if we know A1 and we know D, because up here, the AN formula is this, A1 plus N minus 1 times D. Okay, so all we have to do is plug in. So AN equals A1, which is 9, times N minus 1 times, oops, I forgot my 9 plus N minus 1 times D. D is negative 5. Okay? If we work this out, we get 9 plus negative 5N plus 5, and I get 14 minus 5N. Okay? All right, let's take a look at finding terms. Let's take a look at this here. All right, given the arithmetic sequence, arithmetic sequence 13, 7, 1, negative 5, also decreasing, so D's got to be a negative number. Okay, find A, the common difference. Okay, common difference. So I will do 7 minus 13, right? 7 minus 13. And we get negative 6. So D is negative 6. Okay, so D equals negative 6. B, find the first 6 terms. Okay, so the first 6 terms. Okay, so we already have the first 4, 13, 7, 1, negative 5. 13, 7, 1, negative 5. Okay. So just keep subtracting 6. So subtract 6, get negative 11. Subtract 6, we get negative 17. And those are my first 6 terms. Okay. And then find the nth term. That's that nth term formula. And so an is going to equal to the first term plus n minus 1 times d. And d turned out to be negative 6. Okay, let's go ahead and distribute that negative 6. And we get negative 6n plus 6. Combining like terms, we get 19 minus 6n. Okay. So our an formula is 19 minus 6n. Okay, and then letter D, go ahead and find the 300th term. Okay, so hopefully you're not going to sit there all night long finding the 7th term, the 8th term, the 9th term, the 10th term, etc., all the way till the 300th. You can just use this formula that we derived in part C. All right, so the 300th term is 19 minus 6 times 300. So that is 19 minus 1800, and that gives us 1781. So the 300th term is 1781. Okay, and let's take a look at this next one. Okay, suppose that we know that the 11th term of an arithmetic sequence is 52. Okay, and the 19th term is 92. Find the 1000th term. All right, so let's see what we got here. A1, we don't know, right? We know that this allows us to find the nth term, which means we can find any term using this formula, right? But in order to come up with this formula, we need 2 things. We need A1 and we need D. Okay? All right. But we don't have A1. A1 is a question mark. We have A11. A11 is 52. And we have A19, the 19th term, and that is 92. We don't even have D, right? Okay. But let's take a look here. We know that to get to the next term, we add D. To get to the next term, we add D. To get to the next one, we add D. And we keep adding D to get there, right? So over here, it's kind of like this. Let me kind of draw a picture. A11. is 52, right? And then we would add D. Whatever, we would add D to this, and we would get A12. And then we would add D again, and we would get 13. And then we would add D again, and we would get 14. And then we would add D again, and we would get 15, right? And we keep adding D until we get to the 19th term, which is 92, right? So when you think about it, right here, between the 11th term and the 19th term, we added D 8 times, right? We have to add D 8 times to get to the 19th term, right? So using that logic, then we know that A11 plus 8 times D, because we add D 8 times to the 11th term, and that gave us the 19th term, right? Well, we have numbers for the 11th term, and we have a number for the 19th term. So now we can go ahead and solve for D, okay? So if I subtract 52 on both sides, I get 8D equals 40, so D equals 5. So I have 5, okay? So I have part of my formula, okay? And then I use the same logic, okay? I use the same logic that I did here to go from here to here. I add D 8 times, right? I got that 8 from here, okay? We still need A1. So now I'm going to go work backwards, okay? So here's A1, right? And to get to A11, I had to add D 10 times, right? I had to add D 10 times. So A1 plus how many? 10. 10D gives me A11, but I have numbers for D and A11. D, we said, is 5, and A11 is 52. So now I can solve for A1. A1 equals 2. Okay, so that's the logic behind this here and this here. These are the two things we need in order to write our formula. Okay, you don't have to show this work. I was showing this so that you can follow the logic behind the steps here. Okay, but I'm going to go ahead and erase it so it doesn't look so scary. Okay, you can always rewind. Okay, so really, this was the work. Okay, and what happened was I looked at this, and the difference is here you added 8D, and then between these two, you added 10D to get to there. Okay. Okay, so find the 1000th term. So now I can write my AN formula. AN, so this is just kind of off to the side. And then my AN formula is now 2 plus N minus 1 times D. D is 5. So now if I want to find the 1000th term, I plug in 1000. And then I work this out. And I get 4,997. Okay, so my thousandth term, which is what they were asking for, is 4,997. Okay, so it's more of understanding how many D's you added to get to A19 and how many D's did you add from A1 to get to A11. Okay. All right, so there's our answer. Okay, and then let's just take a look at partial sums, which is very short, so that's why we only have one video. Okay, partial sums. It turns out we actually have a formula for the partial sums of arithmetic sequences. Partial sums. All right, so given an arithmetic sequence, the nth partial sum is given by, and there's two ways to write the formula, so it's up to you to decide which one you prefer. Okay, so you can use this one, Sn equals n times a1 plus an all over 2. You can use this one, or you can use this one, n over 2 times 2 times a1 plus n minus 1 d. Okay. I see students use both, so I don't know which one you're going to prefer. I have a preference. Okay. All right. So we will take a look at one example and then that will be it. Okay. I would say the previous example, this one is probably the more complex of the problems that we've looked at here in this section. Again, there's another way to do this as well, which uses systems of equations. You can take a look at that in the book. But to me, it's like this makes sense to me. Like, oh, okay, yeah, that makes sense. I added D 8 times to go from 11th to 19th term. So then I write out an equation for that. A11 add D 8 times to get to 19th term. And I solve for D. And then this makes sense. To go from the first term to the 11th term, I have to add D 10 times, and I'll get that 11th term. I solve for A1. And then you can derive your AN formula and get the 1000th term. Okay, so this here, partial sums, you can use either one. Let's take a look at this example. Find the partial sum. Find the partial sum of an arithmetic sequence given by these numbers: 3 plus 7 plus 11 plus 15 plus all the way up to 159. Okay, so this one is a little tricky because it's like, okay, well, what are these terms over here, right? I can add these and this one, but then we're missing all the ones in between, right? And then over here, it's like, okay, 159. I know this is the first term. This one's second term, third term, fourth term. But what is this? Is this the 50th term? Is it the 100th term? How far down the road is this, right? Okay, so let's take a look at what we do know. Okay, and let's take a look at our formulas. In order to use our formulas, both of them need to know what nth term that is. Is that the 100th term? because we need to plug in for n. Okay, n. We also need to know what A1 is. Okay, so that's good. We know it's 3. This one, we need to know what D is. Well, that's fine. 7 minus 3 is 4. Okay, so that's fine. But we don't know N. We have the A1, we have the D, we don't know N. Okay, here I have A1, I have the nth term, it's 159. I don't know N. Okay, so either way, either one that you use, you don't have enough information. Okay, all right, so let's see. What do we know? We know A1 is 3. We know AN is 159. And we know that D is 4. Okay? But I don't know N. This is the missing piece. Okay? This is the thing we need to find. Okay? All right. So if we take a look here, we have this, we need the N, whether I use this one or this one. Okay? I only have these here, but I also have a formula that ties these 4 variables together. I can use this formula, nth term formula. AN is equal to A1 plus n minus 1 times D. This formula uses all 4 of these together. Okay, so I can use this to find my n. Okay, AN, 159. A1 is 3. N we don't know. And D is 4. Okay, so 159 equals 3 plus 4n minus 4. 159 equals negative 1 plus 4n. 160 equals 4n. So here I get n equals 40. Okay, so perfect. We get n equals 40. That's what we needed. So that was the missing piece. So now I can use my formula. I'm going to use this one. I feel like this has less to memorize. Okay, so I'm going to use this one. All right, so it said to find the sum. And it's the sum of the first 40 terms. So this here was our 40th term. Okay, because n is 40. All right, so the sum of the first 40 terms is going to be n times a1 plus an. So n, which is 40, times a1 plus an divided by 2. Okay, I can cancel this out. So it's 20 times 162. And that gives me 3,240. Okay, so if I add the first 40 terms together, it's going to equal 3,240. Okay, all right, so that is it for this section, arithmetic sequences. And then the last section we'll cover is geometric sequences. Also has some formulas as well. Okay.